Hey everyone, we are focusing on section 3.4, velocity and other rates of change today. We're going to work through the first 3 pages of the packet together in this video, and then tomorrow we will go over the last 3 pages together in class. So there are 3 concepts of motion that we want to talk about first, and then have some additional vocabulary that we'll go over. So the first one is position, and a particle's position basically determines the particle's position on the x-axis at time equals t, or at any time t. And there's 2 ways to write that. It's either s of t or x of t. Either one are fine. Velocity determines how fast the position is changing at a time t, as well as the direction of the movement. We'll talk about that in a second. And the velocity is then the first derivative of the position. And we have acceleration, and acceleration is basically how fast the velocity is changing at time t. So it's another rate of change. And the sign of the acceleration indicates the velocity is increasing or decreasing. And we write acceleration as a of t, but it's found by taking the derivative of velocity or the second derivative of the position. All right, we have some additional vocabulary pieces we need to go over. The word initially just literally means time equals 0. At the origin, sorry, it's in the wrong spot there, is literally the point 0, 0. Excuse me. And at rest would be when the velocity is 0. If the velocity of the particle is positive, we know the particle is moving to the right. And if the velocity of the particle is negative, then we know that the particle is moving to the left. The acceleration of the particle is positive, then the velocity is increasing. And if the acceleration of the particle is negative, then the velocity is decreasing. You find average velocity by doing your normal secant line or slope formula. So if you're talking about the window A to B, then the average velocity would be V of B minus V of A over B minus A, normal slope formula, which would also be how you would find the average acceleration, just using the acceleration formula. I used different points here, so instead of using A and B, we have X and Y would be the window. So A of Y minus A of X over Y minus X, again, normal slope formula. Instantaneous velocity, so we have done instantaneous stuff in the past. We're just going to be focusing on this velocity here. Instantaneous velocity is literally the derivative of the velocity. And finally, if the velocity changes signs, then the particle is changing direction. This is the one, we'll probably use this one a lot. So if the velocity goes from positive to negative or negative to positive, then the particle itself is changing direction. A lot of little vocabulary pieces. If you need to stop and go back to write them down, please do so. Okay, we're going to go over 3 examples together. They're kind of complicated. That's the whole reason that I typed everything up initially, is I want to make sure I don't forget to say anything or do anything. So we're going to do an analytic example first, that kind of AP style. Then we're going to do a numerical, which is also an AP style question, and finally graphical. These are 3 big topics for AP. They like to be able to solve problems in these 3 formats. Okay, so we have this particle, and its position is given by, notice it's x of t here, and it's given by this whole entire function. And we want to know at time equals 0, is the particle moving to the left or to the right? Well, we know that if the particle is moving to the right, then the velocity must be positive, and if it's moving to the left, then the velocity must be negative. So we first need to find the velocity, which would be the derivative of this thing. The thing is, it's just a simple power rule. So we're going to find the derivative of that position. I did call it S, sorry. So there's our derivative right there. And the question is, at time equals 0, is it moving to the right or the left? Well, I'm going to substitute 0 in for the velocity, and I find that the velocity is 9. So therefore, the particle is moving to the right. Okay, same kind of idea here, but now we're talking about increasing, is the velocity of the particle increasing or decreasing? What piece of advice I would give you is to make sure you read carefully every single problem because there's so many different vocabulary pieces going on. So we want to know, is the velocity of the particle increasing or decreasing? So in order to figure that out, we're going to take the derivative of the velocity. We need the acceleration. So find the acceleration, which is just the derivative of this 3t squared minus 12t plus 9. So that derivative is 6t minus 12. And we want to know, is it increasing or decreasing at time equals 1? So we're going to substitute 1, I should say derivative in there. We're going to substitute 1 into the acceleration, or v prime, and we will get negative 6. So since the acceleration is negative, see right here, if the acceleration of the particle is negative, then the velocity is decreasing. Okay, finally here, it says find all values of t for which the particle is moving to the left. And we're going to do a lot of this in this kind of coming up days here. So find all values of t for which the particle is moving to the left. So that means I need to find the derivative, which we already did. It was 3t squared minus 12t plus 9. I'm going to set it equal to 0, because 0 is when it changes, that's where it's changing direction. So there's a horizontal slope. So there's my derivative. I went ahead and factored out a 3. And then I'm actually going to factor the problem just like that. And these two numbers are going to go on my number line, so we can use our number line method. So I'm actually going to put 0 on there, because that's kind of my starting off point for this moving particle. And then I have a 1 and I have a 3. And I'm going to do, again, good old-fashioned number line. I'm going to test values. So to the right of 3, I have positive values. To the left of 3, but to the right of 1 is negative. And between 0 and 1, I should have positive. And if the particle is moving to the left, then that means that the derivative has to be negative. So we're looking at all of this information, all that space right there. So it's moving to the left from 1 to 3. And we're actually going to see this again when we do the next part of the problem down here. So when we look at the next part of the question, hopefully this will also make some sense as well. So part 4 says find the total distance traveled by the particle over the time interval 0 to 5. Well, here's the thing. We know at 1 and 3 it's changing direction. From 0 to 1, you can see it's going to the right. And then from 1 to 3, it's going to the left, so it's going backwards. And then from 3 to 5, in this case, it's going to the right again. And we want the total distance. So that means this negative or the left distance, I have to actually add that and not subtract it. So I'm going to go ahead and calculate each of these. So S of 0 is 11. S of 1 is, let's see, 15. S of 3 is actually 11 again. And then S of 5 is 31. So we need to add the distances, absolute value distances between each of these values. So this distance is 4, so it moved 4 to the right. Then it actually moved 4 back, but it still moved 4. And then it moved from 11 to 31 again, which is 20. So you're going to add all of these positive values together, and you get that the total distance traveled is 28. This is a different question than displacement, which we'll talk about. Okay, moving on. We're going to talk about our numerical way of looking at data. So this table has time and then velocity is what's given to you here. So velocity over time. Make sure, again, you're reading carefully what you're being given. And the first question says at time equals 0, is the particle moving to the right or to the left? So at time equals 4, we're looking at what the velocity is. And since the velocity is negative, then at time equals 0, the particle is moving to the left. Second question says, is there a time during the time interval when the particle is at rest? Well, that would have to happen when the velocity changes sign. Okay, so it changes sign from between 0 and 2. It goes from -3 to +2. So therefore, there must be at least one place in the time interval where the particle is at rest. And that would be in between those two values of time equals 0 and time equals 2. All right, number 3 says use the data from the table to find an approximation for v prime of 10 and explain the meaning of that in terms of the motion of the particle. So let me move first out of the way here so you can see what that v prime of 10 is. So basically what you're going to do is you're going to find the average velocity, because you can't really find the actual velocity at exactly one time because we don't have that function, but we can compute it with values that are close to 10. So I chose to choose 8 and 12, and we're finding that that is negative a half. Excuse me. Okay, number 4 says that A denote the acceleration, and then it asks you, is there guaranteed to be a time c in the interval that a of c equals 0? So we want to know, is there a time when the acceleration is 0? It's a little bit of a trickier question to come up with. I went ahead and created a table for you so you can see what was happening on these time intervals. So from 0 to 2, you would look at the values and the slope of between those two values is a rising slope. So the graph is going up to the right. From 2 to 5, it's still going up to the right. From 5 to 6, it's still going up. From 6 to 8, it's still going up. And then from 8 to 12, it starts to fall. So we have all these positive accelerations and then a negative acceleration. And what that tells me is there must be a time in there someplace. Let me remember what I'm actually checking here. Where the second derivative equals 0, because that's where the velocity would have a horizontal tangent, and there's a turning point in here someplace. That is because we're going from positive slope to negative slope that has to happen. I was going to draw a graph, but I think you guys could probably figure this out. I would recommend draw the graph yourself. And maybe tomorrow, if you have more questions on that, just ask. All right, last question is a graphical approach. And the graphical approach is pretty common on the AP test. So we're going to go over it. Hopefully, when I go past the graph, you'll be able to look at it on your paper. Okay, question number 1 says that time equals 4 seconds is the particle moving to the right or to the left. Okay, well, we have a positive velocity, so the particle is moving to the right. Common question. Question 2 says, over what time interval is the particle moving to the left? So now we want to know over a whole range of values. And this would be when the graph is below the x-axis, because this was the velocity graph. So that graph is below the x-axis between 5 and 9. So that is when the velocity is negative. All right, and then at time equals 4 is the acceleration of the particle, positive or negative. So we're going to kind of do a test of the slope at that time. So you're going to look at the slope either exactly at that point or use some values around it. It's just a slanted line, and that slope, if you look at the slanted line up here, is negative. It's falling. So since the slope of the velocity graph is negative, then the acceleration is negative. Question 4 says, what is the average acceleration of the particle over the interval? So in order to find that, we're going to actually use our velocity graph and substitute those values into that velocity graph. Well, we're not only substituting, we're just looking at the graph and pulling out the values. So v of 4 is 6, v of 2 is 9, over 4 minus 2. So you get this negative 3/2. That is the average acceleration. And then the next question is probably the most important one here that people tend to get wrong. It says, is there guaranteed to be a time in the interval 2 to 4 where that derivative would equal negative 3/2? And this is actually the mean value theorem. And the mean value theorem only works if the window that you're looking at has no points of non-differentiability. So everything is differentiable. And you'll notice on the graph up there that at x equals 3, you've got this corner point. So it's a point of non-differentiability. You cannot apply the mean value theorem. So the answer to this is no, not guaranteed. Last question. At what time in the time interval is the particle farthest to the right? It is farthest to the right at time equals 5, because that is when the particle has moved as far to the right as it's going to go. After 5, the particle starts moving to the left again because it's got those negative values. So it's moving back closer to the origin. Okay, we will finish the rest of this packet tomorrow in class. And remember to come